So that the same you look at the same very the guru guy the right they have become great. Interestingly, all the three was sitting are our students, you know. But all of them are big, including the respected speaker of today. See, the science form which was started in 1962. So, Nidana Vishnu in 1962. 55 years passed, you know. And conducting Wednesday lectures. Wednesday at 6 p.m. on science lecture. Then about 40 years back we started the science festival. 1 month program, 30 days. Like that, we are at 2,767 lectures, you know. This is a mind box here, 2,767 lectures. And that is going to be short, within minutes, shortly going to be delivered by Marenahalli Prasad, Professor, Department of Mechanical Engineering, Steverd Institute of Technology, Hoboken, USA, on why acoustics matters to quality of life. But one thing is, Wednesday means, it is Wednesday. Be careful about it. No date, no month, no year. Come on any Wednesday, there is a science festival. Of a very good quality also. It's not just like asking, fill the blank. You come and speak or somebody come and speak. It's not like that, you know. Quality lecture. And science festival means July 1st to July 31st. No year. It started in 78, 80, 90 like that. Now we are 2017. Even if you come in 3017, you will have the science festival. No problem at all. And in fact, I am making this comment in front of a very distinguished professor. By chance, if anyone has done this in American University, 2,700 lectures, I will appreciate them. They become first and become second. If you find, you can show me. It's so difficult to get. And already has told me, stellar speakers, the type of persons who are giving the lectures. And the World Science Festival, that was coined by Dr. Agnes Remaya, place of birth is Ramanavami Music Festival at Fort High School grounds. At about 7:30 in the night, somebody was giving the music. My name, you will call, though AHR, you will call me as AHR. The difference is 25 years between me and Chen. I was sitting with him, not only sitting, every time I used to go with him. Always he used to take me. And suddenly he asked me, AHR, see there is a music festival. See there is a Ganesha festival. See there is a Sankranti festival. That festival. Then I told him, what is the fun in that? There are so many festivals. But his mind was thinking elsewhere, and he immediately said that it's not like that. They say, why not to do science festival? I still believe, I still am making with a lot of pride, and I am making this comment, that we were the first people to coin science festival. If you know elsewhere, don't hesitate. Please tell us. They become first, we will become second or second. We need not worry about it. I was here then. Science festival had to know how to do science festival. Then he asked me, music festival means there will come some 5-6 musicians, they will sing. Ganesha festival means they will keep it idle and they will make some, what is that, curd like that, they will eat it. And somewhere a whole year or something like that. Therefore, what we should do in science day? Call some 5 scientists, ask them to give a good lecture. In 1978, we got only 15 members for science festival. Of course, a lot of difficulties there. We have to fix them and they should come here. We don't have money. Of course, then also we never had money. Now also we don't have money. Later also we don't have money because we don't have capitation donation. Now money and number, whatever samsara, but names it out there. National colleges, brand names. Don't worry about the brand name. And 15 marks. That's the way they have all the satisfaction of it. This double man here. Bangalore Margot. University of Science is there, University of Hospital is there, Nimas is there, and so on, Common Institute is there. Double Margo, 1 ವರ್ಷ ಮಾಡಪ್ಪ 30 days imagine, ಒಂದು 79 ಆಯಿತು. ಅವನು ಮಾತಾಡಿದವರು 80 ಬಂದ್ಸತಿ ಮಾಡ್ಬೋಣಪ್ಪ ಅಂತ ಹೇಳಿದ್ರು. ಅವನು 81, ಆಮೇಲೆ ಏನು ಹಿಂಚು ಮಾತಾಡ್ತಾ ಇಲ್ಲ, 82, Success begets success prediction. That means went on like that year after year, and without even thinking about it or worrying about it, where it goes the 170. That's how you can take it. And all lectures are excellent. People have come from America, people have come from different countries, Delhi, Bombay. But one thing, Radha Ramana and college always used to come from Bombay. Later on becomes defense minister. Our key question, Radha Ramana Jackson. What Ramano, if I don't give one letter at the Bangalore size forum, my credibility is at stake. Our Santosha from the defense minister, in the hall, I think you know, somewhere there, function, all over the life. Today, infused with the modern times, we got a multimedia hall. That means these are IP address. If somebody elsewhere on the planet at 4 places, if they have IP address, they can take this certificate. And 200 economic seats for science like that. Maybe in Nasima's time, 4 or 5 people should really put it for science. Ramakrishna was laughing because we're all students. And they used to make fun of Ramakrishna and myself also. That these people, they don't have anything, they are attending they are not understanding. And maybe 28. But today you see that this all of 200, maybe on the first day had come 200 for somebody outside. But today is completely physics topic, Generally physics is hard subject, but a value subject. Without physics, nothing is there. But I cannot take your time. Just go to the ancient, see the name of Yuri Miller, you will understand about physics. From California. How much he is spending on physics, totally. Everybody likes physics, no? Siddharamayanka, you mention any person, any computer scientist, driverless car, it's physics that's important, nothing else, no? In fact, Narasimhaya believed in physics, Ramakrishna believed in physics, myself believed in physics. We had only PCM for 25 years actually, but don't worry. And that's where we built the brand name, and most of our stores are there. Apart from creating this multimedia hall, see the thing there. Exactly it's going on live in the Facebook. People are seeing it. I also requested the speaker, maybe at the end of it, we are taking trial, we should not mistake. 2-3 questions will feed in. Let us say about it, folks. Totally there. And the Facebook means is all pervading again. We are using the latest technology possible, YouTube, Facebook, LinkedIn page, all social media strategy, all the things which are available. We are trying it one after the other. Everywhere we feel we are successful. Because 48 hours back, what I spoke about the Bangalore Science Forum, within 5 minutes, we have of networking, social, the Facebook and other things. 6,000 people are already seen in the hospital. Because Silicon Valley, only our stores are there. Entire hospital, you go, pick up any company. National college students surveyed from 60 to 70. Here at the top. So one national college student, unless Siddharamayanka, which is going to come here, has been nominated to Turing Award, one of the greatest award possible. That's really this announcement. And then, currently, see your thing on 10/7, blockchains. Now, that's the very latest one, And again, now you got a rupee, you got a dollar, you got a yen. Each country, 140 countries, different currencies. Because dollars is always big, If I take my rupee, nobody will accept it. But even in China, dollar comes, they deeply accept it. But according to me, cryptocurrencies will come. That means universal currency. No dollar, no rupee, and other things. Your computer will give you the currency. That means no bank. Bank no person, bank no credit card, no debit card. The entire world depends upon the cryptocurrency. In the Tamasha, Bitcoin in the start, it had a lot of birth and death, not one after. Maybe 2 years back, one Bitcoin was $200. One more is Santosha. It's not illegal, Santosha, but not exchangeable. Whatever is the current. But the same Bitcoin, 1 month back, $2,000. 3 weeks back, $3,000. Last week it is $5,000. People are guessing by about 2018, it becomes $2 lakh Bitcoin. Ethereum. And here, some sort of a distributed technology, where all the things are blockchains, a distributed technology for the people to see. When I asked why in the he told me immediately, only one person was asking, But actually I am studying since 6 months, he said. I am going to give a lecture here. That is, this is an innovation in technology. This is what's called as a blockchain. So if you have an innovation, people will startup will start. Because they start a company, they want to make money. And that is on 28th July, Global Director at Microsoft, he is in Seattle, Dr. Marenahalli, he is not in India, but he will come on that day, 24th of July, 28th will give the chair. How startups use technology innovations to solve India's problem. This blockchain is a technology innovations. In fact, I will go here further. One scientist in America says, it is not the social media, it is not the big data analytics, it is not the artificial intelligence, it is not the robotics which governs the world, it is the blockchain. The entire technology will change. And innovation and startup to solve India's problems, what Modi is trying now. And it is even now, in your house they have some board, they are worried, some thief may come and take away. Crime always is there, don't worry about it. Even in this cyber crime is there. To give you more idea about cyber crime, our Sitaramanga is coming from the Florida International State University to give a talk on forensic analysis for detecting cyber crime. But innovation technology, startup, detecting crime. All are distinguished people, they will attend money. And tomorrow, we have got Dr. Abhinna Chandra Biswas, Principal Scientist, ABB Global Industry, Asia Bombay, speaking on smart grid technology control, and management, everybody knows something about it. Last one is important for you, in residential appliances. In Monday, I told you, mains even passive and paper. Smart grid technology control and management in residential appliances. The whole idea of the sales form is to come to your residence, that concept is there. Each one is good, try to attend with this few introduction today about Marenahalli Prasad, first our student, then Professor and Director, Noise and Vibration Control Laboratory at the Steverd Institute of Technology, got his Bachelor of Engineering from University College of Engineering, Bangalore, Master of Science from IIT Madras, Doctor of Philosophy, Purdue, West Africa, India. Namgir Purdue gets someone starting in Hoboken, Prabhu Namkedra, Professor N. Prabhu, he was Chairman of the Industrial Engineering Department, and all the Bishop with the lecturer. And Chacha Ramakrishna is there. Nani Maklo, Oriental, Yeldan, PhD from Purdue University. Ask Purdue University. One way he can go, Chacha Kela, that's all. I got so much intimate contact with Purdue University. Purdue University is not one. And lot of professional experience. Graduate assistant, graduate assistant, aeronautical engineer, physics and all provided, all departments totally. And awards and honors and citations. Fellow of American Society of Mechanical Engineers, Fellow of Acoustics Society of America, Fellow of Acoustics Society of India, Fellow of Institute of Noise Control Engineering. And then the acoustics someone put a Java academy and fellow. It's not so easy, He is a very distinguished person. And a guest editor, member of editorial board, received ESME Student Section Advisor, elected Director of Institute of Noise Control. He both more than one after that, he was such a distinguished person here. A person said, Chairman of Technical Committee on Acoustics, a member of the Executive Committee of Engineering and Acoustics, Vice Chairman of the New York Metropolitan Chapter. The acoustics was Namul class, which matter like a question. Now the Buddha's law, a question for that and a question that. But if you know specific Raman, there are a lot of that, The only noble are in India. So controversial statement matter, the plans there. Indian sisters there, they are not Indian sisters, they are so physics Nobel Prize, only one Indian is specific Raman. He got in 1930s and the 30s. You are 2 0 1 7. So you will commemorate the silver, you will commemorate entire of specific of Indian Nobel Prize. Government ministers along. Yet, important. Until now, we never got one more page. We are not supported. Having that in mind, at National Institute of Advanced Studies, myself, Balram, Dr. Kasturangan, Dr. Maya, Siddhara Maya's prodigy program, extremely interesting program. Every year one thing will happen. And then activities as given to professional societies and extracurricular activities, literature, performing arts, philosophy, acoustics, history of acoustics. But T.S. Subrahmanyan in Mappa, history of science is 21 days daily. I think we carry on history of acoustics. One day put it there. First lecture, second lecture, third lecture, like that. Acoustics setting is known, covers different branches of life. Last one is chess. Naturally, should be really person. That is the subject. Thank you.
Thank you, Dr. Ramram, and thanks for every one of you for taking time in the nice evening to listen to me and to be part of this great festival. It's indeed it's a great honor for me to be part of this celebrated science forum, and that to Bangalore Science Forum and also my alma mater, college. And I should tell that in my life, two things have impacted in my career. The first one is National College, because in our time, National College was the ivory tower, and I made into that. So that is so. And of course, having come here, met teachers and mentors who changed my life. And in all subjects, physics, mathematics, and Sanskrit, English. So I can never pay enough gratitude for this great institution. And then the IIT Madras, where I began my encounter with this wonderful world of sound, and which made such an impact in my life that I said I will spend my time, my professional time, in this world of sound, and you'll see because sound really is another dimension to explain the universe. Of course, light is there, but sound, as the famous Kavi Dandin says, if you remove the world of sound, if you remove the sound from the world will be dark. So it is so the world of sound started from IIT Madras, and I continued my learning in the field, and still, of course, we are all students of science, because science teaches every one of us. So with these few thoughts, I would go into what is the connection between acoustics and quality of life, and why does acoustics is important, and is it important? And we will see at the end of the presentation that I hope I will make some impact on those who might be still questioning, because I still remember that this sound and noise and the environment is something that people normally don't pay too much attention. But as you will see, it has reached the global dimension, the whole field of acoustics. So with that, this is a brief introduction to our campus for those who might not be knowing where Stevens Institute of Technology, it is one of the oldest universities in America. In 1870 it started. The celebrated American Civil Mechanical Engineers was founded here, and then of course this is the Empire State Building, which is in the Midtown Manhattan. This is the Manhattan, the celebrated city in the world, and this is our campus. And it's right on the bank of the Hudson River, which is going all around Manhattan, and this is our major administration building, and here is our building right here. So, and our noise and vibration control laboratory is in the Department of Mechanical Engineering. And so here we are talking of two terms and the connection between them. Acoustics, of course, acoustics is a word that came from Greek background, which refers to the science of sound that deals with generation, control and transmission, reception and effects of sound. This is something important because when you take the process of sound, there are three things that matter: the source, the path, and the receiver. All the three are important. And this is a generic model. We can use this model for describing anything. If you are sitting in the house and the car is going in the street, the car is the source, and I am the receiver in the house, and anything that is connecting between that and me, including the distance from the car to the house, the surface of the wall, the leaks in the window, then my interior structure in the acoustics of the wall and all that, so that becomes the path. So source path receiver is a very powerful model in the environmental studies. So if you take a car, for example, car is the engine is the source, muffler is the path, and the person who is walking in the street who is exposed to that becomes the receiver. So to study the three things, we need this source path receiver. So whatever we do to understand that becomes acoustics. Then quality of life is referred to the standard of health, comfort, and happiness experienced by people. This quality of life is defined in a normalized way by United Nations. It's not that I make the definition. It's defined based on the world population, world demographic, and world status of technology and society and all that. So it defines what is the standard of health, comfort. This is where we come into the definition in relation to acoustics, and of course the happiness experienced people. If you go to a music concert and if there is a heavy air conditioning running and you want to enjoy the music and here is the thing, so obviously people are unhappy, and that affects directly the quality of life. So like that. And then another important term that we are going to look a little more detail is noise. And now noise basically refers to unwanted sounds or detrimental sounds. So there are two aspects here. Now if a sound becomes unwanted, which means I don't like it, that is an unwanted sound. To give a simple example, if the dog in my house barks, it's okay for me. But if my neighbor's dog barks, then I become very annoyed. What is this? So there is a psychological aspect here also. So that is unwanted. Then there is detrimental. It could be somebody in my own family playing the music or playing the musical instrument. If he comes and plays right into my ear, I like the person who is playing and I'm very happy and all that, but it is detrimental. It's going to hurt my ear. So it doesn't matter whether you like it or don't like it, the ear is going to get damaged. And that's also very important in the field of acoustics. So we are going to look at how does that affect our quality of life. Now here is a very ubiquitous picture of sound. sound is all pervading, as we said earlier, because sound needs airborne sound, I'm referring, needs medium, and of course air is all around. So we are actually swimming in the sea of air, as we can describe in a literary way. So we are all exposed to sound all the time. Even when we are sleeping, our environment which carries the sound affects us. So that is why sound environment is very much impacting on the sleep. And we will see how critical it will be in a few minutes. So here is our the world of sound. If we take the engineering sciences, so we see acoustics here and electroacoustics and buildings auditorium. Then of course here we come into the music. And music is a branch of physics in a sense that there is an engineering physics in which we study the design of musical instruments. So music can be seen as there's a whole field called physics of music. So all those things come here. Then the psychology and physiology, there is a whole area of that in terms of the hearing conservation and the psychoacoustic. Then of course we also have underwater thing. So it's not that sound is only detrimental or important to humans, but it is important for marine life, it is important for the birds, all the things are affected by sound. We will see some of that. Then, so to give a basic difference between noise and music in a quantitative way is here, noise affects us because it is the irregular succession of waves, so or shocks that is called. While a musical sound flows smoothly without any asperity or irregularity. So this was the definition that John Tyndall, who was one of the great British experimental physicists, gave in 1867. So now let's compare that to a very recent one, the definition between noise and music. Noise is an irregular waveform, whereas music has frequencies that are harmonic component of the fundamental wave is nothing but the music. So we can see that music is pleasing, whereas noise is unpleasant sound. So if you see a waveform, we can see that it is our noise and it is our music which is amenable to the well-known Fourier series, Fourier transforms. So that being fundamental, 2 times the F fundamental, 3 times fundamental, 4 times fundamental, like that. And at this point I might draw your attention to one unique contribution of India to the world of music, that is Mridangam and Tabla. See, if I hit this is a percussion instrument. Nevertheless, I can use it for rhythm, tada. But it is not harmonic. We don't want to listen to this for long. But like a tabla and mridangam, you can keep listening because it is melodic and which comes from the harmonic. So up to first 5 frequencies, first 5 harmonic, they are integral. So that's a very unique in the world of music. So then here is an interesting riddle. What comes with the carriage and goes with the carriage, and of course the carriage is right here, is of no use to carriage, and yet the carriage cannot move without it. So it's like an old puzzle, and the answer is noise. Because anything that moves, as William Brand told, that anything that moves produces sound. Why? Because if I move my hand like this, I'm inducing a pressure on the air particle. The moment I'm inducing a pressure on the air particle, I'm increasing the atmospheric pressure. So once I increase the atmospheric pressure, that difference in pressure is perceived as sound. So any movement, the only difference is because it's a low frequency, my ear doesn't perceive unless it becomes 20 cycles per second. If If I can move my hand more than 20 cycles per second, you will actually hear my movement of the hand. So noise is derived, if you look at the etymology of the word noise, it's very interesting. It came from the Latin word nausea, nauseating, so uncomfortable, making stomach move around. So, and earlier definition in 1930, noise is sound out of place, very beautiful definition. So, what the sounds were supposed to be outside has come to inside, like dirt coming inside the house. And the current definition is noise is unwanted sound. So there is a relationship between the two. Then, in terms of the noise level quantification, we have the definition, which I'm sure many of you are very familiar with it, sound pressure level, that is the unit that is used, and if you define that 20 times common logarithm RMS pressure in the air here, compared to the just perceivable sound by the normal human ear, which is 20 micropascal, defined by that, determined by the laboratory. So anything that increases or decreases with respect to that becomes our sound pressure level. Now this number is important because whenever we talk of acoustics, we have to say decibel, what dB it is. So that gives an idea. So to get that number into our common understanding, this is very helpful. So if I take whisper, if I whisper to someone in their ear without making sound, then it's about 30 decibels. So, and as we go in a quiet room, in a very bedroom for example, night time it will be between 30 and 40. Then we come into normal conversation, it is 60. And we can, as we go vacuum cleaner, now we are increasing 70 to 80 decibels. Hair dryer, it is one of the very noisy appliance which people use all the time because we use it very regularly. And motorcycle, 90 decibels. And then we come into 110 or 130, extremely loud, and of course the painful, 140. Now, the maximum sound level that we can theoretically produce is 198 decibels. Why? Because atmospheric pressure is 14.7 psi. So I can go up to 14.7 psi, right, increasing the atmospheric pressure. So that translates to about 198 decibels. And in presence of 198 decibels, it's guaranteed the ears will simply shatter into pieces. So we will never reach that kind of thing. So 140 itself pain, severe pain occurs. And so that is why we keep that. So this is an important thing to remember. Now, coming back from in the reverse direction, if that is so critical, then what is the nature of our ear? That is the mystery of biology, maybe we can say that. Why? Because ear is very sensitive. That's the reason that human beings are very susceptible to sound pressure level, noise level. So eardrum, tympanic membrane is 4,000ths of an inch. So you can see how small, it's a very thin membrane, very thin membrane. And the ear canal is about 1 inch. So if you take the resonance frequency of an open and a closed tube, then it is about 1000 hertz. So what happens is, around 1000 hertz there is a resonance. So whenever a sound comes in, if that is around 1000 cycles per second, then there is resonance. And what is the problem with resonance? The energy will transfer very easily. Resistance will be lower. That means whatever the energy that's coming in directly goes into the auditory nerve and gets into the brain. That is the interesting point with this. And that can be seen very clearly here. So earlier we talked about the magnitude of sound. The other important thing about sound is the frequency. Frequency. You will see that. In frequency, what happens, nature itself has made what is known as a natural filtering behavior in the air. So, we can see that here, up to 1000 cycles, there is upward, the curve is here, right? And after 1000 cycles, we can see it is more like going deeper and then coming up. So 1000 cycles is our reference. Now below 1000 cycles, what is happening is, our ear acts as a muffler. Let me give one example. If, for example, we are hearing this sound. Now, we are not annoyed by this. If you focus a little bit, it may be kind of going to recognize it. But it's not coming in the way. It is low frequency. If the same thing will be high frequency, then it will be a problem. Why? Because our ear becomes sensitive. So this is the human ear perception, is the behavior of this. So now there are two things. One is the sound waves bring whatever the frequency is. Then when it goes through the ear has a filtering of this nature. And so the human perception is what we call as the A-weighting. So it's a weighted behavior of the human ear. So it's called as A-weighting. So that's an important thing. Now here you can see that these are the low frequency sound sources and these are the high frequency. And this is the painful threshold of pain. You can see about 130, 140. So this is called as the equal loudness curve, which was developed by actual people listening to the sound waves. This is not a theoretical one. This is actually developed by the real experiment, real people. So now here is I want to show you an audio demo, and audio is not working. Yeah, very good. So I have three examples here. One is this is our diesel generator engine side, and here we have a sentence, and we can see in presence of background noise how the audio is heard. Now here is a part of the lab, and here we can see it is little better. And here this is the anechoic chamber of our laboratory, and here the sound is very clear because the background noise is almost zero or relatively zero. So we'll Okay, I think you can believe me.
Okay. No problem.
Okay. So basically what it is very simple, masking. So I can give you some visual examples. Suppose I am talking to someone in the family room with another family member. Now, if the TV is off, we can hear each other quickly. But many times what happens, we forget to put off the TV. So TV's voice is also, the TV is running. Then we are talking. Then we say, what did you say? Like that we keep saying. And we will forget, we don't even worry about putting off the TV. So the only way to get a good hearing is to put off the TV and then pay attention to the person talking. So that's something like that, you know. Okay, so this, now what are the sources of noise? This is something very important. Aircraft noise, industrial noise, recreational noise, which is one of the leading sources nowadays. Then automotive, cars and trucks and all that. Then the rail noise, train, the metro, and construction noise, which is also another important, trucks and trains and all that. So all these noise sources is coming and affecting the person in the dwelling. So we can see that our goal is to make that this is a quiet environment, this environment inside. So all the sound that is coming from here have to be understood in terms of the frequency behavior, and we have to understand the path and of course the interior design. So the whole aspect is what is the acoustical engineering or acoustical science. So now, why global noise has become a global phenomenon, world phenomenon. Now when we look into the world around, very interesting things come out of this. Now in New York, noise has been for several years #1 complaint, and in fact there is a separate helpline 311. Like 911 for emergency, 311 is for noise complaint. And it's very noisy in New York. So very interesting thing. In Paris, 59% of the people said that noise is the biggest nuisance. In fact, it is more than air pollution. Very difficult to believe because air is very important for us breathing, but people are affected by noise. Sleep gets deprived and communication gets deprived. So, and in Norway, 30% of people are exposed to high noise levels as World Health Guidelines reveal. In Moscow, of course, 70% of the people live with unacceptable noise levels. In Australia, we think Australia is very quiet and all that, but 40% are exposed to high levels of traffic noise. And so, Korea, 63% of people complain noise levels are very serious. In Bangkok, Thailand, 20% are exposed to high level noise levels. In India, China, Bangladesh, Pakistan, noise levels are very high, and actually they exceed the World Health Organization guidelines. Although efforts are being done, but still the noise levels are increasing. Now, in terms of why these noise levels are affecting so much is because that interact directly with our life. So, if we look at our exposure, that is how many hours or minutes in exposure, and dBA, this A refers to human perception. If it gets a dB, it does not include human perception. It has to be a dBA because A refers to the human filtering. So, if we look at the levels and the exposure duration, we can see that, of course, the common sense tells us that lower the level, longer the duration, higher the level, shorter the duration. So that is very obvious. But there is a trade-off in the sense that if we go for 8 hours, because 8 hours is our work day, right, for daytime work hours. So we can go up to, if we go up to 8 hours, we can go up to 80 to 85 decibels. If you look at here, it's about 85 decibels. But if I go for 110 decibels, then I can only, if I come here, then I can go only 30 seconds. So if it is a 110 decibels, I can only expose myself up to 30 seconds, half a minute. So whether it is a recreational noise or whether it is a traffic noise, it does not matter. So this is one of the problems we acousticians are feeling, because the young people are going into band music, rock band, all these band metal music, very loud, and they are losing the hearing pretty much. And I know many people in there who are band players who in their mid-40s have lost hearing considerably because they were playing in those music bands very close to the instrument. So this is a very critical thing. So one has to make sure that one does not get exposed to very high levels. And thing is 8 hours, 85 decibels. So every 5 decibels increase half the time. So if I am exposed say for 85 decibels for 8 hours, then for 4 hours I can only go up to 90 decibels. 95 2 hours later. So we have to remember that formula mentally and make sure that we don't get exposed. We have to take care of that. Now, if you take a normal routine of a person, of any one of us, this is what happens. So we sleep to 6 o'clock, then we get up around 6. So you can see our level should be in a suburban environment, that means away from the city, our level should be about 35 decibels in the house. And if it is an urban environment, we can go up to 55 decibels. Then when we start our day, we see our instrument up to 90 decibels. As I said, this is the max I can go for. If anything more than that, then we have to cut down the level. So then we come back, then of course you can see the level coming down, then still we come down, and by the time we are back to sleep, we are back to 35 decibels. So you can see very nicely our interaction with our work and life is very closely connected with the sound sonic environment. So it is something that we have to recognize. Now another way we can show that in a very nice way is distance between the speaker and the listener. Now if the distance between the speaker and the listener is far, then the background noise has to be low. If the background noise increases, then the speaker and the listener have to come close. Very common sense. But again, it has to be quantified. So we can see here, between distance, if it is 1 meter, we are right here. 1 meter is about 3 feet. That is the normal distance in two people talk. So for that distance, if you take 70 decibels, around 70 decibels we can have somewhat normal conversation. But if you make it 80 decibels, then I have to shout. This is a very interesting experience, and it happens many times. When you are walking in the street, two friends walking, and we will be talking in normal voice. Suddenly a truck, a lorry comes. Then I shout. Immediately start without knowing they raise our voice. And that affects us. One other interesting thing is the acoustics and biology have a very close interaction. Because if we shout, we become tired very quickly. Because we use the whole body to produce speech. It's a very interesting thing. Because for smelling we may use only the nose. But for speaking we just don't use the mouth, we use the whole body. That is why people get tired when they become angry. Because they shout, we raise our voice. So, and 100 decibels, impossible conversation. It's just not possible. So the best method is to keep quiet. That's the only way. So, and we all have gone through this. What is known as a cocktail party effect. So if you take a picture of a cocktail party effect, say there is a gathering, in the beginning everybody is coming in. So people are breathing and noise level is very uniform. But as the time goes by half an hour, then what happens, people start becoming clustered. Because I can't hear what this person is saying, but I can hear what this person is saying. So if that is of interest to me, I will go here. I won't go there. So like that, then what happens, it becomes circles of concentration of sound levels. And that is known as cocktail party effect, which has been studied very scientifically, and there are many articles in the Acoustics Society journals on this. Very interesting area. Now, another interesting thing that has been studied is age-related. Now, the industrial society has increased a lot of comfort for us. We can never imagine our life without blenders, without hair dryers, without television, without microwave, refrigerator, all these things. But we also have pain in a way. That is, all this industrial environment has impacted our hearing very much. Industrial society, we are talking of 70 decibels gone by the age of 80. So the mobile prime, which basically means people who are not exposed to urban noise level, their hearing is protected. And in New York City, as you can see here, this is our hearing loss. So this is a very interesting, this is called presbycusis, which is a very well studied phenomenon. Now, what are the effects of noise on our psychophysiology? And it has been proved beyond any doubt that the noise has many effects. As you can see here, the changes in the intestinal motility. In fact, people who travel in metro, subway in New York, for long 2 hours like that, they are studied and they can actually feel something because of the high noise level. And then we also have certain changes in heart rate and increased sugar, stress-related effects on diabetes and all that. It's all been studied. So we can see that these are the very direct effects of noise environment. So it's very critical that how we expose ourselves. So, to put it in World Health Organization WHO guidelines, so what are the adverse physiological effects? The hearing impairment, which is very clear, and interference in speech communication, which we talked about, sleep disturbance. This is a very critical one also, because when we are about to sleep, if the noise levels are not within the limit, then we don't go to sleep. And by not sleeping or awakened from a good sleep will put us in a very negative effect. So that is one. Sleep disturbance is a very critical one due to noise. Then we have the physiological effect to cardiovascular. So all of these are the biological effects of noise. The whole society is studying the biological effects of noise. And what are the psychological effects? The mental health effects. Now, mental health effect is it contributes to the nervousness. And it's a very interesting thing. People who work in the punch press, especially in a heavy industrial environment where the banging is happening, people are not able to think there, right? So it's just a labor type thing. But it's not good. So that's the mental, and we know that in the library, if the noise level is high, nobody can concentrate and read because it's direct effect on the focus. It is the impact and negative social behavior. This has been studied in a social aspect. That is, wherever there is a heavy noise environment, there people tend to get angry quickly and restless. So, one interesting thing, especially when we are driving, we can see it very clearly. See, we got a new place, new environment, and we are looking for the street name written on board. So, we have our radio on, some music. Now, if I am not able to read the street name, and I am trying to look for the name, immediately we reduce the volume of the radio. So this was studied. Why? Why should we reduce the volume of the radio if you are looking to read the name of the street? Because this is disturbing. So the radio is disturbing me to focus on my eyes. So interesting behavior, and that is what is annoying. So all these are very tangible effects. So what are the effects of noise pollution? It is estimated that in 2016, the number of people who suffer from hearing loss over 25 decibels, and it is very significant, 25 decibels loss, is more than 700 million or 9.3%, and hearing loss over 40 decibels is about 5%. So in United States in the world, in the United States alone, hearing loss is projected to affect 40 million by 2025 and 2050, 53 million. So it's and loss of hearing is seen as a very serious loss of one of the faculties. That is why people who have hearing loss, they get isolated much easily compared to other handicaps. So it's our challenges. So it's a very serious one. And another interesting thing is hearing loss is cumulative. That means it keeps adding. Whereas water pollution is immediate, it's not cumulative. If the water is first one time itself we say water is bad, we don't drink anymore. But sound is not like that. If it is a little bit more, oh it's okay, it's okay. So we keep adding. Called invisible cumulative pollution. So that is the challenge there. And in the US, hearing loss is the third largest widespread chronic condition. So this is the effect of noise pollution. So what are the recommended noise levels according to World Health Organization? In environments like hospitals, hotel rooms and spaces, 30 decibels. Indoor dwellings, bedrooms, as I said, 30 to 35. Outdoor activities, 45. Outdoor activities, 50 to 55. So we can see this should be our environment that we are exposed on a day-to-day basis, whether in the house or outside the house. So we can remember 30 to 55. That is the range. But when we go into workspace and the other commercial activity space, we can go up to 70. But when it comes to the music, headphone listening is another serious issue. It is never advisable to put hearing the music listening by the earbuds. It's better to put over the ear, because if you forget to keep the volume down, it is a direct hit on the tympanic membrane. That has been studied, and so it's very important. But what happens is people, in order to forget the effects of environmental noise, we keep the earbud. But that is not a solution. Then public address system, outdoors and indoors. This is a very critical one. With all respect to the various religious festivals that happen, in particular in India, whether it is Ganesh Chaturthi or call of prayer in mosques, it doesn't matter. it does disturb the environmental quality of our life. That is why at least in the Western countries, very serious conditions and enforcement. I was involved myself as an expert in a festival that some people complained that the noise level is high. So then I had to go and actually measure at various times and then show it to the board that it is within the limit. So it's a very serious thing. And that's something that enforcement of law is very critical in noise. Because you can write anything in theory, levels should be less than 40 decibels. It's very simple to write the sentence. But if it is not enforced, nothing matters. So enforcement is very critical. So global noise standards. So this is the permissible levels that World United Nations has recommended to the World Health Organization. So we can see here, Argentina to India is about 90 decibels here, and 85 decibels, and you can see that this is allowable. And something very interesting in Norway, they go as low as 55 decibels. So we can see that the levels, but again, as I said, constant monitoring is very important, and enforcement. Now, some examples of some of the work that I myself have been involved. Briefly, I will share it with you. So here is the construction noise in New York City, and you can see that here that before any construction work, construction activity begins in New York City, the company has to measure the noise level over the period of 24 hours, both weekday and weeknight, and ambient, that means background noise, as well as with the operation. And then we have to show that it is well below the limit level. Otherwise, permission will not be given. So there is a body that reviews from the city or the government, and they are very, very meticulous on that. Why? Because if the residents complain, that's the bigger problem. So we have to go in for the company to make the measurement and prove it. So we can see that over the period, we got period 1 and period 2, depending on the weekday and weekend. At 4 corners we had to do it, and we showed that it's about 82 decibels, whereas the ambient noise itself was about 81 decibels, and 86 decibels on weekdays and 81 on the. So by showing this, then we have to get approval from the city government. Now, in order to control the noise, in another project, we were involved in designing an enclosure. And as you can see here, this is not a small enclosure. This is like a big house of this size actually. So you can see here, it's about 45 feet high, and it's about 130 feet here, this long. So we can see, and within that there is a construction equipment which is doing the metro work. So digging the ground to reach the underground station and all that. So this is the enclosure, the whole thing. And then we have to show by prediction, and also we have to measure and show that this meets the requirement. Now here is another, don't know whether this will work. Yeah. I don't know why the audio is not working, but again you can see the picture. So what we have here is a blender which is untreated. And this was one of our design projects where our undergraduate students took this blender untreated and did the noise control treatment on this and reduced the decibel from the red to the green. So it's about 10 decibels. Now 10 decibels reduction is a very significant reduction. Why? because it's a logarithmic scale. So log 2 to the base 10 is 3. So every 3 decibel, we are reducing the power by half. So if you reduce 10 decibel, you are actually reducing by 1/5 of the power, acoustical power. And that is a very significant one. So that is why 10 dB is a very big thing. And we can see the frequency spectrum and how we can see here the reduction of the red to the green. And of course the treatment has to be designed such a way that it does not interfere with the performance of the blender. Now here is in the hospital. This is another very important area nowadays in the world. That is in the hospital. In hospitals what happens, people are coming as patients to get treated. Now we are going through a lot of experimental scanning that, this and all that. And all of these are creating a new noise environment. Now what is happening is we are finding that these increase in noise levels are affecting the patients in inducing nervousness, in inducing tension and all of that. So which means hospital acoustics is a very critical one. So the strict requirements have to be met there. And we can see that these are the kind of equipment and we have to measure such a way that we have to bring in the level down. So we can see that the levels have to be brought to the lower levels around 50. Otherwise it will be 65 to 70 and it is an unacceptable level. And interesting thing, and at least in US we have seen a lot of noise related street signs. So we can see that here 80 decibel noise limit. This is the road limit. And excessive noise 58.4. Unnecessary noise prohibited. And another interesting thing, if someone honks in front of a hospital in US, that person will be fined pretty heavily. So it's a significant penalty for honking, unless it's an emergency, and it has been proved in the court. So you can see that it is taken seriously on the street. Now, this is another interesting thing. I commute to my university. So in the train, there is one compartment. Earlier, of course, we used to know smoking was very much in all compartments. Now, we can smoke free. So now what they are doing is, we have noise-free compartment. So it's very interesting actually. So once you go and sit in that noise-free compartment, you cannot speak. You can, in fact, if anyone tries to speak to you, then the conductor will come and then escort you, take you to another compartment. So it's really a very interesting experience because you can read, you can think, and you can listen to music and all that. And even the phone, you are putting in vibration, not zombie. So that is why it's called a quiet commute, and it's quite popular. So now, few words on the goodness of sound. I spoke only on the badness of sound because it's important to know that. Now, goodness of sound, of course, we all know it, and for Indian music, I don't have to tell, we all know it. And music therapy is becoming a very effective mode of therapy for patients in US. There's a whole wing in hospitals on music therapy. And music lowers the stress, improves health, music helps people sleep better. Music strengthens learning and memory. All these have been shown in classrooms. And music relaxes patients. And music helps Alzheimer's patients remember. This is another interesting thing because in Alzheimer's it was found that people still remember very clearly the rhymes and the nice songs. Like Twinkle, Twinkle, Little Star, How I Wonder, how big thing, I can remember very clearly, but not what they did in last 10 minutes ago. So, and here, this is an interesting thing. I do work on the aspects of acoustics in Hinduism, in Vedic tradition, because the Vedas are nothing but collection of mantras, and mantras are nothing but precise acoustical utterances. We cannot make mistakes in swaras, udatta, udatta, swaita. So basically it is an acoustical output to the precision. And recently UNESCO recognized and celebrated Vedic oral tradition as humanity's intangible heritage forever. So it's a very interesting recognition that the United Nations did for itself. So, and here is the conch shell and then the shofar. Shofar is an interesting instrument in Jewish tradition. It's a ram's horn, and it's a very curved horn like this, as you can see. And when you blow through it, it produces like a French horn, beautiful tones. And then, so I'm used to get conch shells. So we made a presentation on the acoustics of conch shell and shofar with my colleague, and we were amazed, we were very surprised to see the similarity of the acoustical quality very nicely. So we can see in a conch shell, we can get a very clear harmonic. And the quality factor, which basically means the sharpness of pitch is very unique and something that's very important. And I don't know why I had a very nice audio, but anyway. So that is about the acoustics of conch shell. Then I also did some work on bamboo flute with Pythagorean scale. Very interesting similarity. The Pythagorean scale we were able to see correlating with the experiment here very clearly. You can see that the theory gives this ratio and in various notes, and experiment also comes 1.09 to 1.07, 1.14, 1.3, and this is a bamboo flute, a typical bamboo flute dimension. And here is a nice clip of this is the flautist V.K. Raman playing flute. Very sorry for the audio. Then we have, so we're almost coming to the ending thing. So what is that we have to do then? We have recognized the problem that noise is a serious issue of the global scale. So what has to be done? Now, if we look at the history of noise regulation effort, it started very early in 1800. There was something called the UK Red Flag Act. And there were a lot of campaigns about anti-noise. And then we came in 1900, what is known as the public awareness campaign. Then, of course, more strict rules were put, and California was one of the leaders in mid-60s to bring the aviation noise regulations. Then the famous one was 1972 Noise Control Act in US, which really brought major movement and effect in the noise research. And then we have now the European Union. They came up with very good noise regulations, and recent years, and of course that will never go away. That will keep going. So what is the future? Future is very simple in terms of prediction. If we don't have any noise regulation or no improvement in noise regulation, noise will keep going up, and as the time goes. Then if you have a strong noise regulation, it will come down. Then if it is a weak noise, obviously somewhere in between. So this is the way we want to be here. And it is possible. The noise research is not a rocket science. It's not a rocket science. But having said that, why most of the countries are not meeting that? That is a very big question. And that means citizens have to become very aware and very strong in enforcing, in demanding the government to do the proper enforcement, and the industry have to adhere to the noise requirement. So it is both awareness and enforcement. Both have to come together with understanding of the acoustical science. Because education can bring, if once we come to know, if I'm exposed to noise, my hearing will be affected, then I have to become alert. If I don't become alert myself, then my boss is not going to be, my employee is not going to be, because their interest is profit. So there is a lot of science, technology, and the government, all are very closely involved in this. And so that is so here is a kind of humor, noise reduction. It's not a luxury, So I don't think everyone can afford an expensive noise control person like that. So just to end with my literary side of the brain, I wrote a poem on this mystical world of sound. I'll read it. Oh sound, you surround everything around. You are everywhere to be heard. You are outside but also inside. You are ever produced in nature. You come from humans and machines. You are with motions and patterns. As an annoying noise, you displease someone. As a diagnostic tool, you are useful to someone. As a painful noise, you can hurt anyone. As a soothing music, you comfort everyone. It is not easy to place you as music or noise, either wanted or unwanted. You are always sound. So, thank you, and I'll be happy to have any questions.
Good evening, ladies and gentlemen. It was very beautiful talk, sir. You have come all the way here to enlighten us with this concept. It has been very informative and interesting, sir. On behalf of Bangalore Science Forum and all of us here, I propose what I can do, Dr. N.D. Tomorrow's talk is by Dr. Abhil Chandra Biswa, Principal Scientist, ABB Global Industry and Factory. He will be speaking on smart grid technology, control and management in residential appliances. All are cordially invited. Any questions, please?
Good evening, sir. I had a question for you. I live on a street which is getting increasingly noisy because of the vehicular traffic. So, on a practical basis, I heard all that you said, but as a layman, as a citizen who is directly affected because I can't shift residence as I own the residence, what do I do to mitigate the effects of noise pollution? Is wearing earplugs the only solution, or could I do something else than that?
As I said, we have to see the three components, the source, path and receiver. If you can reduce the source noise we should do that because that is the best one. To put mufflers on the vehicle to make sure that each vehicle produces less noise. If that is not possible, if it is not in our control, then we have to think about the path. Now the path, again, there are various aspects. The distance between the vehicle, the traffic to the wall of my house. And that if I can increase, but I cannot, because that's also not in my control. So the only thing I can try is to work within the house. So I have to change the environment. Again, that costs money, of course, and so how much we can do that, and that depends on individual situation. Because by changing the, for example, if I have a double wall, instead of single wall, if I have a double wall in area, I will reduce the 6 decibels.
I understood most of the time it's the windows that's the problem.
Yeah, even for windows also, we can do double window. There's a double window concept also, that can be done. And then we have to make sure that the leakage of the windows have to be fully controlled. And double pane windows are in use. Again, it's a structural change, it costs money. So it is as I said, it's a triangular thing. Citizens, industry, government. So government have to play a role. Otherwise, if the government doesn't care, then it's a problem. Because how much we can spend our money, within the thing. So it is a complicated problem, but it's something that we can do ourselves, and we can afford to spend money, then we have to do that. So we have to make sure even within the house, we can create more absorption, so that the sound, whatever comes in, will not be reflecting back and forth. So people build studios. Of course, there they have a business interest. So they spend money so that they can earn money to the. There are 3 studios now in Bangalore, just coming here. Very well done, like Prabhat. But of course, it's all commercial. So it is done, but government has to be brought in US in particular. If the citizen complains, he can go to the mayor, he go to the elected official, court also. He go to the court, bring the elected official, and it has to be, because noise is nobody's property, it's government's property.
Unless you get to make, don't ask question, no?
Sir, I read it in an article that the sounds comes from sun. It's similar to like O. Is it true?
There is that what they call the thermal noise, which is a kind of humming sound. I have listened to some YouTube sound. It can be humming like home, but again, that is something that we have to listen and we have to think that. Because the home itself is a mystical thing. So one can only find a similar characteristic, like conch shells glow. That also comes like that. So there is a thermal noise effect. So it can resemble something like that.
Yeah. Actually, you need not worry, no? You can't go out. Each one of you should play question.
Good evening, sir.
Yeah.
How do you measure this noise level? What is the instrument for measuring noise level?
Measuring noise, there is something called sound level meter. And it's something that you can measure dB sound, dB air. And nowadays smartphones like Android, iPhone, we can get free apps like that, application. And you can get sound level. Actually, I have one. I can right now measure it and tell you what it is right here. So we can measure Yeah, it's about, if you don't speak at all, it's about 54 decibels right here. So, of course, you can speaking, it's about 80 decibels.
So one more question. Is it the Mach number is related to this first place? Mach number?
Yeah. That is the Mach number is particularly the aircraft noise. Yeah, obviously, because if it is supersonic aircraft, there is something called shock wave. And of course, the limit is Concorde. Just like a stop because of the noise. The Concorde flew, I think it had 2 or 3 flights. And that produced shock wave. And the shock wave phenomenon is very interesting. It comes like a N form. So what happens before it's coming is one sound, big sound will come. Then there is a silence. Then as it passes the area, then another super. So it's like a N shape. So, but that is one actually. Aircraft noise because more than the velocity of the aircraft, the exhaust of the aircraft. So is a very noisy source. So aircraft noise is very, especially in the takeoff and landing. That is why many times aircraft will come on the water if possible, landing over the waterbed, or where there is no residential. It's a very big topic in aircraft noise.
Workplace noise. Workplace noise.
Workplace noise.
When it is normally between 80 and 85,
for 8 hours.
comfortable for 8 hours.
Yeah.
For every 5 or so, it comes down to 50%. So
Correct, every 5 dB.
Acha, whereas we see in contrast to that the point, the people are working from morning to evening, day by day, continuously in industry and other locations where the noise level is high, but still they are not affected.
No, they are affected. They are affected. It has been studied. They are affected. See, the effect, as I said, the hearing loss first shows up in the high frequency. The 20 to 20 kilohertz is our audio range. So, if you go and take audio hearing test, we lose first the high frequency. See, about 10,000, 12,000, many people who work in high noise environment cannot hear. Then why we don't feel that is because our speech range is between 250 to 4,000 hertz. So that is our God's gift in our life. If that doesn't get impacted that easily, it gets impacted only when people put the earbud at very high level. They start losing it. So industrial, the 80 decibels for 8 hours is studied only on that noise workplace. So if someone is working for more than 8 hours, in more than 90 decibels, over the time they will have the hearing.
But what I understood myself, maybe right or wrong, the person becomes accustomed to that, situation and his biological and nervous system maybe appreciating some situation that may give some support for his heart to. Is it maybe right to some extent, sir?
No, what you are telling is correct. What you are telling is correct. We get adjusted, but that is not a good thing. See, what happens is, I'll give an example, you might have heard of this. A person was working in a very noisy environment. Then what happened, a person was, that person was brought into, he was promoted and brought into an office environment, where the noise level is very low, but he couldn't work. He couldn't work actually. He said, hey, that is not a good thing. Because to get used to noisy environment is not a good thing. Right? That is why most of the people cannot sleep with noisy environment. So,
Sir, can you throw some light on acoustic materials?
to mask the sounds?
Yeah, the acoustic material to absorb the sound basically. Yeah, that will absorb the sound, right? Yeah, very clear. The acoustic materials are used like a thermocol and fiberglass, glass wool, and even some material which are made from bagasse, because what it needs is a porous material where sound can enter through the pores and then reflects back and forth and gets absorbed. So that is the principle in the material work. So anything that has that property will absorb. But anything like some bad designs are done. For example, people have nice fibrous material, and then in order to make it look good, paint on that. And that is not helpful because the paint does not allow sound to get in. So it reflects back. So sometimes those mistakes are also done. So materials play a very big role in.
I still remember HM being associated with our indoor auditorium. You can still see it's all porous boards.
Correct.
Your thing reflected the clearest example in this.
Okay.
And don't mind if I
Yes.
So, I stayed on the neighbor of National College. The earlier gentleman asked how to control the pollution on the road.
Correct.
So I was associated. I had a building coming up next, and it was completed. But that was not the problem when the construction was going on. The problem started when the construction was over and the whole interior was done. Whole was handed over to a customer who had installed a lot of exterior air conditioning fans.
Correct.
So over the night, neither the neighbors could sleep over the night because the decibel level went up. Usually at night it was about 35-40 decibels on this, that we call it wine glass room. So then when this fan started over the night, it went very high. And it was disturbing sleep for all of us. And I took the initiative and started complaining to Karnataka Pollution Control Board. And they acted very well.
Oh, well, yeah.
Srilinga was then I think, chairman. He came personally and saw this building. It was built by the prestigious Brigade Group. So they are very powerful than the neighbors, class neighbors all around. But they took a decision and made certain arrangements. Over and over we complained and they came and showed the decibel meters and it was got down up to 55-60 in the night.
Yeah, that's bad, yeah.
So maybe the initiative by all should take this into because our government is acting, it is not sleeping.
That's very good news, and that's what I wanted to hear.
Sir, unluckily we couldn't see your audio demo.
Here
I saw in the first slide, 75 dBA was this one. But when you have put that acoustic observers around it, then it was showing 35 dBA or something. At least the 40 dBA sound has been absorbed by that acoustic.
The anechoic chamber.
Anechoic chamber.
Yeah, what I can do is, if I can just try 1 second, there is a computer on, yeah. Idella ಇದು direct to you from direct to the computer.
What exactly you wanted to tell by this demo? That's what I wanted.
Yeah. Well, give me 30 seconds. Yeah. I think we can hear the sound in this mode, not in the slide mode. Let's see.
Sir, ಏನಿಲ್ಲ ಅದರಲ್ಲಿ 3 ಲೆವೆಲ್ ಇದೆ ಸರ್. ಆ 3 ಲೆವೆಲ್ ಗಳಲ್ಲಿ ಏನು ಕೊಡ್ತಾರೆ? ಫಸ್ಟ್ ನೀವು ಸರ್ಟಿಫೈಡ್ ಏನು ನೆಕ್ಸ್ಟ್
70 decibels ambient noise. ಯಾಕಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಡೀಸೆಲ್ ಜನರೇಟರ್ ಸೊ 70 decibels ಅಲ್ಲಿ ಒಬ್ರು ಮಾತಾಡಿದ್ದಾರೆ ಕ್ಯಾನ್ ಯು ಹಿಯರ್ ಮೀ ನೌ ಅಂತ 70 decibels ಅದು ಕಷ್ಟ ಹೇಳೋದು ಯಾಕಂದ್ರೆ 70 decibels ಇಸ್ ಆಲ್ಮೋಸ್ಟ್ ಲೈಕ್ ಸ್ಪೀಚ್ ಲೆವೆಲ್ ಅದಕ್ಕೆ ನೆಕ್ಸ್ಟ್ 55 decibels
ಬಾಂಡ್
ಅದೇ ಲೆವೆಲ್ ಆಮೇಲೆ ಕೊನೆಯದು ಅಲ್ಲಿ 35 decibels ಅವಾಗ ಕ್ಲಿಯರ್ ಆಗಿ
So any anechoic chamber will have 35 dBA.
Oh yeah, 35 even lower will be. That's depending on the size of the length of the wedge. A wedge is at 2 feet to ಮೇಲೆ ಇದ್ರೆ ಇದು ಕಮ್ಮಿ.
They only qualify.
ಹೌದು.
Thank you, sir.
Yeah.
Sir, can I ask you a question, sir?
Our sound also from better. No, not like that. It looks that a rail is for the present and good decision. Firstly, we can go to stage and questions to you. Thank you.
Okay. For those who are interested, if you can